Hello friends, welcome back to the bench. Our patient today is Asus Prime Z370A. This is the board that we have already diagnosed, which had liquid damage, short on V-core. Right? Let me show it to you under the scope. So this is our liquid damage, which probably is a soda, maybe coffee, which most likely is a sweet liquid, which means we're gonna use 70% isopropyl to clean that. But on top of the liquid damage, we have shorted transistors over here, right? And this one, if I remember correctly, no, this one is low, or was it this one? Yeah, oh no, that was the cap charging. Yeah, so high transistor is shorted, definitely, and I'm guessing because one of these was getting hot under the thermal camera. So I will actually, this is the single line. These two coils and these four transistors is a single line for V-core, right? So we don't have any shorts over here, right, on this line. Oh, I stand corrected. Okay, we have a little more short than I thought. Oh, that's weird. Yeah, I guess they are connected. Let's check the board view. I will check the board view in a second. Because what we want to do is just use this board as a donor. This is the one I can't figure out. We diagnosed both of these, or actually we diagnosed this one. This one we didn't diagnose. It doesn't work. As soon as you connect the V-core, it turns on, and after roughly a second, maybe a little less, it turns off. We checked the how voltage rises on V-core and VSA and VGT. It rises correctly, it rises to the correct level. No idea what's wrong with this one. Some kind of feedback. It could be that the PCH is faulty in some way, and that's why it turns off. Hard to say, but even with putting in the CPU and connecting V-core, it still flashes CPU. So that kind of suggests that there's some issue with PCH. So at this point, I would love to fix this one, but at this point it becomes a donor. Now, I will start removing, so first we gotta clean it, then I'll start removing those transistors here. Maybe I'll inject, I'll probably inject the voltage again, because surprisingly, again, we don't have the short on V-core when we inject here, when we test here. Oh well. And before, when I was injecting voltage here, it grabs full current, and afterwards, oh, that makes sense. So afterwards there would be short. And the reason for that is I just realized the gate on the transistor was charged. And there's probably no discharge resistors. Or if there is a discharge in the control chip. Each phase over here has a control chip. This one, this one, this one. Right? We have 3 rails over here. these two, and these two are connected in parallel. The transistors in question are roughly 60 amps at 30 volts. The difference between the high and the low transistor is very minute. The low transistor has slightly higher drain current, ID or IDS, drain source maximum current, continuous current, and that is a difference by about 2 amps. So no big difference, but there is a significant difference in input capacitance. So the low transistors have significantly lower input capacitance than the high transistors. Maybe that's why they're different. I'm actually not sure why different transistors are used for high and low. But we're just going to replace probably, well, since I'm catching shorts everywhere here, I do remember it was probably this one, but after cleaning it, I'll inject some voltage and check again which one it is, and most likely I'll just replace the whole set. So this entire line, I'll replace all 4 transistors over here just to be sure, and I'll check the injection again. But first, let's clean it. Okay, so it looks like we have a pretty weird issue. Well, maybe not weird, that was kind of to be expected. So I keep removing everything that is getting hot when I inject 6 volts. I'm injecting 6 volts at 2 amps. And as you can see, once I remove those two, we're no longer pulling full current when I just inject to the between the ground and 12 volts in, right? So I'm measuring the transistors outside the circuit to see which one is going to be showing short. None of them is showing short, but one is showing 10K, which probably once you start pushing current through it, the resistance drops. So this one, I'm not sure left one or right one here, this was one of the culprits. But I'm still getting short on the high transistors. However, now when I inject right between the drain and source, I'm pulling everything, it's dead short, but I don't see anything getting hot. And that usually happens when the short is very wide, capable of pushing a lot of or conducting a lot of current. So I need to wait for the board to cool down from all the soldering and stuff and see if we can spot on the thermal camera which transistor or which component is responsible. It might be tricky. I will likely have to, in either case, I have to remove all the transistors, and the reason is because in between the drain and source underneath we have liquid, and that liquid can cause, that it shouldn't be there. We need to clean that. So either way, each one of these transistors need to go off the board, and since I know transistors on the other board work properly, I'm replacing every single one. But I want to wait for the board to cool down and see if I can spot a heat spot.
Stranded in the open, dried out tears of sorrow, lacking all emotion, staring down the barrel, waiting for the final gates to open to a new tomorrow, moving with the motion, following the light that sets me free.
Alrighty, the short is finally gone, and surprisingly, this is the transistor that was shorted. This is not one of the ones that was lighting up on the thermal camera, but this one definitely is like completely dead short. Let's turn the beeper on. Yeah, dead short. Oh, and it's also shorted to gate. That's not good. That is no bueno. If it's shorted to gate, then likely our control circuit is fried. So that is definitely bad news. But that is a very bad news. Because where am I gonna get the control circuit? But before we jump to conclusion that it's the circuit, the control circuit is broken, let's continue removing the transistors and cleaning underneath.
does. Search, but you stay lost. We are reaching for the stars, but we're making this too hard. And I wonder where you are. Mysterious, that's the part you always show. 'Cause you're too curious. Maybe you
Alrighty, that took way too long, but I was expecting that there's going to be short when voltage applied. And why did I expect that? One of the transistors, this one, was shorted between drain and gate, and source and gate. It was pretty much wire, three-way wire. So 12 volts went onto the driver. Now that's why I was soldering on 4 transistors at the time and injecting voltage, because this kind of fault is not going to be revealed by the meter. You check the meter, it's fine, but as soon as you apply the voltage, the gate opens because the driver is shorted and you have a short. That's why the working transistors were lighting up on the thermal camera. So I expected that at least 4 of these, at least one line would be catching short. And then I figured I'm just going to discard that line for now, because that's going to be enough to boot into BIOS and, you know, even the system when the one rail is going to be missing. We got 1, 2, 3, 4 rails. So let me check that. 1, 2, 3, 4 rails. So I figured if we just discard one of them, we can still test the board, just to answer the question. But I'm injecting voltage and it's fine. Now the majority, the 12 transistors, are reused. I tested them with the diode reading and discarded anyone that was not showing 0.45. Some were showing 0.5 and above, some lower. So I discarded every single one that was not reading exact. It did not have the exact same reading. Meaning 4, if I calculate correctly here, 4 transistors. But for some reason I used 8 from the new board. Oh, right, because I have, right, and I have 4 over here that I haven't used because they were not paired. So now all we have to do, let's check the work. It's not work of art, but it should work. As you can see, we have some melting over here, which is fine. I mean, we'll see if it's fine, because this will affect this heatsink. It might not lay properly on the transistor, so we'll see about that. But other than that, it looks okay. So now the only thing left is, and it does start, obviously the CPU doesn't turn on, and our, oh right, because the other problem with this board was that we didn't have LEDs lighting up. Probably SIO. But since we got already this far, let's see if the CPU issue is resolved. So at this point, when we were turning it on, the PSU would turn off due to short. All right. Let's check again then. Yeah. Well, it's not. Yeah, that's gotta be a SIO issue. But just to satisfy my curiosity, the CPU, the maximum power on this board that the CPU can deliver, that can be delivered to the CPU, is 65 watts. So we're giving it 50 watts. That should be fine. Now let's turn it on, and yes, we had 600 milliamps. So it's better, because before our PSU would turn off. Now it's the board that is turning off. It's the exact same behavior as this one. So it turns on without vCore. When you connect the vCore, it turns on and off. If you guys know what that is, definitely drop it in the comment. Another one, no fix. But this was a long shot. I know. It's with the previous what do you call it, diagnosis, which was the short on vCore and no LEDs lighting up and stuff. That was kind of it was very much possible that would be the issue. What I'm thinking on both these boards, once we get through the initial process where SIO is involved and perhaps EC, we enter the next stage where PCH is trying to establish communication with the CPU and detect memory, detect devices and all that, and pass it over to the BIOS. That is the process that most likely terminates the procedure at this point, because something is wrong, and that is most likely on the PCH at this point is my diagnosis. Now what exactly? Well, here's the deal. There's no way I'll be able to replace the PCH. I mean, I can desolder it, sure, I can clean the board, sure, but then I would need pre-bold PCH to replace. And after that replacement, there's definitely gonna have to be some cleaning you need to do to the BIOS after replacing PCH. There's definitely, that's not something that I would do on the board that is worth maybe 80 bucks, maybe 120 bucks. Not much more than that. This one, yeah, well, say it's even 150. There's no way I'm gonna attempt such a repair on such a cheap board. But that is my diagnosis at the moment, that it's the PCH. At least, well, I don't know how much does that tell us, but at least even though the transistors or one of the transistors got shorted completely to a wire with the gate, it did not damage the drivers. So at least we have a nice answer there. But other than that, the board is trash at this point. The more boards with the same issues I have, the quicker I'll figure out how to fix it. Alrighty, thank you very much for watching, and I will see you guys in the next one.